Let's look at solving linear equations. The first thing we need to think about is look at the variables and see how many variables you have in your equation and do you really have an equation. And in this first example, we really do have an equation. I can see the equal sign there. I can see the equal sign there, and I see that I have two places where that variable is appearing, and it's an x. And so what I want to do is get the variable to this, both variables to one side and combine them as like terms and get the numbers to the other side. So I'll show you how we do that. So starting off here, first thing I want to do is I see I have a 2x on the left and a negative x on the right. So if I add an x to both sides, it's like a 1x. Then I have a 2x plus a 1x, so that gives me 3x minus 3 equals, and then I have a 3 there, nothing happening to it. I have negative x plus x. So I have an x and I'm taking away an x. So I have nothing in terms of the x's on the right-hand side. So I essentially moved it to the left-hand side. Now the next thing I want to do is move the 3 here. So add a 3. That's going to move that 3 from the left-hand side over to the right-hand side. So whatever I do on the left-hand side of the equal sign, I have to do the exact same thing, signs and everything, on the right-hand side. So here I have 3x minus 3, 3x plus 3. The negative 3 and the positive 3 are going to cancel just as the x's did. And so I'll be left with 3x equals, and then 3 plus 3 is going to give me 6. So I'm not quite done, so I'll rewrite it up here where I have a little bit more space, 3x equals 6. And then what I want to do is get the x by itself. So the next thing I need to do is divide by whatever my coefficient is, which is the number part in front of the variable. And if it's a fraction, I'll just multiply both sides by the reciprocal. But since it's just a whole number, it's easy enough to think of it as just dividing by that number. So I'll divide both sides by 3 here. And 3 divided by 3 is a 1, so I have 1 times x, which is just x. And then 6 divided by 3 on the right-hand side is a 2. So my solution is x equals 2. And what I want to do is check that. And what checking means is that you're trying it out for the value of x and seeing if it works. So for here, I just plug it back into the original equation. That way I'm checking all my work, not just my last part of it. And so I have 2, and I multiply by that 2 for the x. So I'm plugging that in. Let me just show you that in a different color for where I plug it in. That might help a little bit. So I plugged in a 2 there. And then the equation says minus 3 equals 3 minus, and then I have to put in what I had for my x again, one more time because x showed up 2 times, remember. And then I can go back and simplify more. So I have 2 times 2, that gives me 4, minus 3 equals 3 minus 2. Well, 4 minus 3 is 1, and 3 minus 2 is also 1. So I have an equality or a true statement, and that means that my x equals 2 is a valid solution for this equation. Now, if we tried any other number, what we're saying is that x equals 2 is the only solution. So if I tried some other number, like say 4, it should come out to a false statement, and that would mean that 4 does not work in this equation as a solution for x, a thing that you can plug in for x and still have a true statement. All right, let's look at another example. This one is 2x minus 3 equals x, and again I see I have a variable and it is x, and I have it in 2 places, one on each side of the equal sign. So what I want to do is move the x's both to the same side of the equal sign. I can choose either side to move them to, and on this equation I see that I have a positive 2x on the left and a positive 1x on the right. Now normally I would move the smaller coefficient, the term with the smaller coefficient, I would move it to the side where it had a bigger coefficient on the x. But in this case, I want to do it a little differently because I have the negative 3 over here, so I might be able to save myself a step or two by just moving the 2x away and having just the number left on the left-hand side. And it'll work out either direction that you decide to use to move your x. So I'll show you this direction. So I have 2x, a positive 2x, and then I have a negative 2x. Those are going to cancel. and I'm left with a negative 3 on the left, and then I have a positive 1x and a minus 2x. Remember, you can think of that as a 1. And so I have a 1 minus 2, which is just a negative 1x or a negative x. You can look at it either way. The last thing, again, I want to get the x by itself, so I'm going to divide both sides by whatever the coefficient is, which in this case is a negative 1. So divide both sides by negative 1. And on the right-hand side, my negative 1's reduce to a positive 1 because I'm dividing something by itself. And so I'm left with x equals, and then I have negative 3 over negative 1. And so that is negative 3 divided by negative 1, and it's a negative divided by a negative, so it comes to a positive 3. So I had to deal with negatives a little bit more by moving the term with the larger coefficient, but I saved myself a step because I didn't have to move the 3 to both sides. So you could work it either way. I could also do the other direction. I'll just show you that real quick. And you can see which way you prefer. So on this time around, I'm going to subtract x from both sides. And I have 2x minus 1x, so I just have x minus 3. And here the x's cancel, and when something undoes itself completely in this way, you have a 0 left over because I have a positive x and I take away an x, so I have nothing or a 0. So then the next step, I have to add the 3 to both sides. And when I do that, then the 3's here are going to cancel or give me 0, and then I have x equals 0 plus 3, or 3. So I didn't have to deal with the negatives on that method, but I did have to understand that I was getting a 0 on the right-hand side and then use the 3 on both sides to counteract. Okay, so last thing I really want to do is check that. And so to do that, I'm going to try my x equals 3 and plug it in. So I have 2 times, there's where my 3 goes, minus 3 equals, and then there's where my 3 goes again. And so I'm going to put them in with a different color pen just to make it a little bit obvious for you. And then when I combine things, I get 2 times 3 is 6, minus 3 equals 3. And 6 minus 3 does equal 3. So that's a true statement, and really I am checking to see if those are true. I tend to leave the question mark off, but it's implied that I'm checking it and it could come out to be false. But this one came out to be true, so I know that my x equals 3 is the correct solution.